Okay, let's start the section. My name is Sumit Sagar Hota. I am a PMRA PhD scholar IIT Palakkad, and today we will discuss week 8 of the live discussion section by Professor Ashok Desar, IIT Kanpur, Introduction to Airbreathing and Propulsion by NPTEL. Okay, we will discuss some of the theoretical questions and as well as some problems. Okay. The prerequisite for this section is you have to at least watch lecture 36 to 40 by Professor Ashok Desar of the subject Introduction to Airbreathing and Propulsion. Okay, so this is the first question. Combustors dash pollutants increases, decreases, remains constant. Okay. Okay, what is that means this question is about the working of the combustor. Okay. Okay, the combustor always what decrease the pollutants. Okay, answer is B. Combustor always decrease the pollutants. Swirlers is the dash part of the combustor. Okay. Okay, so in this question, why it is so decrease the pollutants? Because what does combustor do? It will assure that fuel is completely burned. Okay, or when fuel is completely burned, then the what pollutants will decrease. Okay. Next question, Swirlers is the dash part in the combustor. Okay, Swirlers always the first part of the combustor. Okay, what does Swirler do? It induces swirling motion. Okay, and it's in the first part of the combustor. Is fuel are given for what? Flow stabilization, flame stabilization purposes in the combustor. Okay. Okay, next question. Nitrogen oxide are released from dash. Okay, so this question is given for confusion. Always you should remember nitrogen oxide obviously released from combustor, everybody knows. Okay, but if you choose A option, then it will be the wrong. Okay, because in burners also different kind of burners are there. Okay, Bunsen burner, many kinds of burners are there. There also nitrogen oxide is very harmful gas. It's also released. Okay, so the option is always C, combustor and burners, not only combustor. Okay. Okay. But how you represent nitrogen oxide? Always most of the people tell NOx. Okay. X can be any number. It can be 1, 2, 3, whatever. Okay. But it's a oxide form of nitrogen. Okay. Combustor and burner. Okay. Next question. The carbon monoxide pollutant released from the combustor is emitted during dash process. Okay. CO is there. Okay, that means oxygen is present. Okay, so the process cannot be what? Reduction. Okay, CO is released in nowhere. It's obviously if in nowhere, then why this question is set? None of the mentioned. If none of the mentioned, why this question is set? Okay, so obviously the answer is oxidation. If oxidation is not there, then that may be the option can be none of the mentioned. Okay, so like that you can approach. During oxidation process, nitrogen oxide are produced during combustion zone. Nitrogen oxide are produced during, obviously I now told you nitrogen oxides are there in combustor and burners. Okay, so obviously it's true. Okay, next question. When afterburners are not used in jet engines, they are what? Obviously, okay, afterburners if not used means that the in the jet engine, then the there will be two options. There cannot be any semi-dry. None of the mentioned cannot be the case. Either it will be wet or it can be dry. Okay, so afterburners are not used in the jet engine because it's the exhaust gas become what? Dry. Okay, that's the reason it's not used. It will dry the exhaust gas. because exhaust gas are dry. Okay. Which is dry the jet engine. Okay. Okay. Next question. Afterburners are not equipped with case and liners. Obviously, if somebody making some system dry, then obviously there must be a liner. Okay, that's a very common thing. Okay, case is there or not, because this is a closed system, so obviously case should be there with afterburner, and obviously liner is also there. Okay. The answer is false. So afterburners are equipped with case and liner. Okay. Next, afterburners have dash rise in temperature than combustor. Okay. Obviously, afterburners are having high rise in temperature than combustor, and why the reason I will tell. So T of afterburner is greater than T of combustor. Okay, so rise in temperature is the delta T. So what exactly afterburner? Okay, so in afterburner always there is some what? Exhaust gas. Okay, afterburner name suggests after burning whatever thing left. After burning, what are the things left? Obviously exhaust gases. Okay, so exhaust gases having less temperature or high temperature. Obviously exhaust gas having temperature high. Okay, so exhaust gas having high temperature. Okay, and again if you add for some fuel plus oxidizer, maybe air, okay, and burn. Okay, already the temperature is high. Okay, then you add the fuel plus oxidizer and then burn. Okay, but here in the case of only gas is there, low temperature, then you add fuel plus oxidizer and then burn. Whatever the temperature here will be obviously what? Low, and here it will be high. So answer is high. Then mixing of fuel takes place efficiently in afterburner. Obviously it's false, okay, because in combustor it's efficiently burn. Afterburner it's not that much efficient. Okay, maximum fuel not efficient in what? Afterburners. Now afterburners require what? Very common term. Afterburner casing is a part of afterburner, so it does not require casing. Casing already there in afterburner, so casing cannot be the case. None of the mentioned there, then why this question is there? So it's not the case. Nozzle afterburner, how nozzle become the part, and where is the nozzle? Nozzle is there near your turbine, not in the burning part. Okay, so this nozzle also wrong. So only one thing left, flame holder. If you don't know what is flame holder or what is all these things also, no, just remove all the other options, directly we get the answer. Okay. So answer is A. Okay, why this flame holder? Let's see. Afterburner. Require flame holder. Okay, and why? To maintain constant velocity. Of flame. Okay, to maintain constant velocity is there. Okay, next question. Next question is our problem. Propane C3H8 is used as a fuel in an engine with 30% excess air. Assuming complete combustion, determine the composition of exhaust gases on mass basis. Atomic weights are C12, O16, N14 and H1. Molar ratio of oxygen is what? 3.76. Okay. So this is what the question. Okay, so let's do the solution. So propane reaction is there. Okay, so first write down the propane's general reaction, chemical reaction. Okay, C3H8 plus X, coefficient we don't know, O2 plus 3.76 N2. What does it mean? This is your air. Okay, gives rise to 8 times CO2 plus B times H2O plus C times N2. Okay, so now what you have to do? Okay, you have to find this A, B, C and X. Okay, then only you can get all these things. Okay, first you do which balance? Carbon balance in the left and right hand side. Okay, so it's equal to what? How many carbons are there left? C3, so 3 carbons are there, and here also 1 carbon, so A is equal to 3. Similarly, H balance you do. H8 is there, so 8 is equal to anything else in left? No. So right hand side, yes, it's there, 2B. Okay, so that is B. B is equal to 4. Then you do oxygen balance. Okay, what are the oxygen there? 2X. Okay, in left hand side. Right hand side, how many oxygen? 2A plus B. A we know what? 3. 2 into 3 plus B is your 4. 6 4 4 10. So what is X? X is your 5. So you get A is your 3, B is your 4, X is your 5. Okay. Okay, if you get this, then you have to find out what? N2. Okay. Then 7, because you see here X equal to 5 into okay, so you write down 2 into N2, this is for N2, 2 into 3.76 and write down N. Okay, so 2 into 3.76 X is equal to 2C. Okay, X you know 5 is equal to 2C. So then what is C? If you solve, you get C as 18.8. Okay, now next is mentioned in the question that 30% excess air is used. Okay, 30% excess air used. What does it mean? That means when there is air is there, na, air is 1 now, C3H8 plus here you multiply 30%, so 1.3. Okay, into X is your 5, O2 3.76 and 2 gives rise to 3 CO2 plus 4 H2. Plus now let it be D times O2 because E times N2, because you see here now excess air is there, so excess air means some oxygen species will come. Okay, so so D and E now you have to what? Find out. Okay, so that's the reason why here also you see nitrogen is there, C and 2. Okay, so here I find out the C, then substitute here. Okay, now D and E is your requirement. Okay, so again you do the what? Oxygen balance you do. Oxygen balance, how many oxygens are there? 1.3 into 5 in the left hand side is equal to what is there in right hand side? 3 into 2 plus 4 plus D times 2. Okay, now when you solve this, you get the value of D as 1.5. Okay, similarly again you have to do what? Nitrogen balance. Okay, okay, just balance. See, 1.3 into 5 into 3.76 is equal to E. Okay, sorry, 2 times E. Okay, so 1.3 into 5 into 3.76 into 2 is equal to 2 times of E. Then what is your E? 24.44. Okay, so now you get your E. Okay, now you have to find out the mass. Okay, CO2, H2O, O2, N2. Okay, all these mass you have to now find out. Okay, so CO2, so mass balance you have to do. Mass analysis. Okay, so okay, so here in the question what it's asked, the assuming complete combustion, determine the composition of exhaust gas on the mass basic atomic weights are given. Okay, determine the composition of exhaust gases. Okay, in exhaust what are the gases present? Okay, gases or everything you have to take. It's water vapor. Okay, so CO2 present, because excess air is there, so CO2, H2O, O2 and N2 will be present at the exhaust. Okay, and you have to find out what are the percentage of them. Okay, okay, first what you do, mass analysis. So CO2 you do, so CO2 is equal to 3 into 44. Where this 3 came, number of moles of your CO2 is 3 and 44 came from the what, your C is 12, O2 is your 16. Okay, so I'll write down, this is the molecular weight, C is your 12 plus 2 into 16. Okay, so total value you get 132. Okay, similarly H2O, what is the number of moles of H2O? 4. H2 1, H1 O16, 2 into 1 plus 16, 18. So multiplied 72. Then your O2. How many moles of O2? 1.5 because D is 1.5. Okay. O2 is your 16 into 2. Get 48. And 2 24.44 number of moles. What is N2? 2 into 14. 14 into 2. Okay, so you get 684.32. Okay, you add it. Total mass. Okay, mass actually is not the mass. Okay, you really see what exactly is asked in the question. I want to check. Complete composition. Okay, composition of exhaust gas. Okay, composition means so mass fraction. Okay, in percentage you have to find out. Write down total mass. One 32 plus 72 plus 48 plus 684.32. What is the value you will get? 936.32. Okay, total mass. Okay, just now take the ratio. What ratio? Percentage of CO2 is equal to mass of CO2 divided by, okay, mass fraction means how you represent mass fraction and mole fraction. Always remember, mass fraction will always represented by the letter, capital letter Y. Okay, so write down Y of CO2. Okay, that is mass of CO2 divided by M total into 100. 100 means it's percentage. If you don't write a percentage, no problem also. In the question it's asking percentage, so I am converting in percentage and I am writing. Okay, so 132 divided by 936.32 into 100 is equal to 14.09. Y of H2O, M of H2O, M total into 100, okay, is equal to 72, 936.32 into 100, okay, is equal to, this is your answer. Okay, 7.69 percentage. This is your answer. Y of O2, M of O2, M total 100, $48, 936.32 into 100, 5.12 percentage. Y of N2, M of N2, m total 100 is equal to 684.32, 936.32 and 200 73.08%. Okay. Okay. Okay, next question. Okay, so next question. Air enters a convergent nozzle from a reservoir at 2200 kilopascal and 100 degrees Celsius. If the exit area is 4 centimeters square, what is the maximum mass flow rate that this nozzle can handle? Assume the process to be isentropic and that R behaves as an ideal gas. Okay, so first you draw the diagram. This is your reservoir and this is your nozzle. So this is your reservoir. Okay, so this is your convergent nozzle. (2200 kilopascal) and what? 100 degrees Celsius. Air is going, okay, coming out from the nozzle. Okay, just apply the what are the things given and directly write down what are the solution. Okay, so your what is the gamma? Air is there, na? So a gamma of air is here equal to gamma is equal to .4. Okay, so P star P naught 2 by gamma plus 1 gamma by gamma minus 1. What is P star then? Two by gamma plus 1 gamma by gamma minus 1 into P naught. Okay, substitute the value and find the answer. P star equal to 2 divided by 1.4 plus 1. Okay, 1.4 divided by 0.4 into 2200. Okay, gives rise to 1162.22. Okay, kilopascal. Okay, so now T star T naught P star by P naught to the power gamma minus 1 by gamma. So what is T naught? 100 plus 273 1162.22 divided by 2200 0.4 by 1.4. Okay, so the value comes out of T star as what? 310.83 Kelvin. Okay, this is your P star. Okay, got T star P star. Now our work will be easy. What is sonic velocity? Okay, sonic velocity always represented by C star square root of gamma R T star. Okay, 1.4 R of air 287 joule per kg Kelvin. T star 310.83. Okay, what is the value of C star? C star is your 353.4 meter per second. Okay, now rho star. What is rho star? Ideal gas equation P star by RT star. Okay, 1162.22 0.287 310.83, 13.02 kg per meter cube. Find m dot rho star A C star. 13.02 4 by 4 centimeter square it's given, so 4 into 10 to the power minus 4 into 353.4 your sonic velocity. Substitute. Find m dot as related to m dot star. M dot star as 1.841 kg per second. Okay. So mass flow rate required to find out, and this will be your what? Answer. Next is the long question of gas turbine. Okay, so next question. An open cycle gas turbine employs a regenerative arrangement. The air enters the compressor at 1 bar and 288 Kelvin and is compressed to 10 bar with a compression efficiency of 0.85%. Sorry, 0.85%. The air is heated in regenerator and then in combustion chamber till its temperature is raised to 1700 Kelvin, and during the process the pressure falls by 0.2 bar. The air is then expanded in the turbine and passes to regenerator, which has 75% effectiveness and cause a pressure drop of 0.2 bar. The isentropic efficiency of the turbine is 86%. By stretching the gas turbine system and showing the process on TS diagram, calculate the thermal efficiency and power output if mass flow rate of air is 100 kg per second. Take mechanical and alternator efficiency at 98%, CPG 1.15 kJ per kg Kelvin and CPA 1.005 kJ per kg Kelvin. Okay, these are the things given. So first we draw the what? Cycle. 1 dash 2 dash 1 dash 2 dash 2 x 3. Okay, isentropic 4 dash actual 4. Okay, this distance 9.8 bar. Okay, and this is your 0.2 bar. Okay, this is your 1 bar, 288 Kelvin. Okay, this temperature 3 is your 1700 Kelvin. Okay, maybe here one point will be your y. Okay, so let's solve this thing, TS diagram. Okay, solution. First write down isentropic relation T2 dash by T1 is equal to P2 dash by P1 to the power gamma minus 1 by gamma. Okay, let's solve it. So T2 dash is equal to T1 10 gamma minus 1 by gamma 288 into 10 into 0.4 by 1.4 556.04 Kelvin. Combustion efficiency T2 dash minus T1, T2 minus T1, so T2 is the actual temperature, which is equal to T2 equal to T1 plus T2 dash minus T1 divided by NC, compressor efficiency. Okay, 288 plus 556.04 minus 288 divided by 85% compressor efficiency 0.85. So T2 you get as 603.34 Kelvin. Okay, So T4 now you have to find out. Okay, now what do you know? T4 dash divided by T3 is equal to P4 dash divided by P3 to the power gamma minus 1 by gamma. What is CPZ? CPZ gamma R by gamma minus 1. So what is CPZ? 1.15. What is gamma? Need to find out. What is AR's R value? 0.8287 divided by gamma minus 1, because gamma is not given in the question. So gamma comes out to be 1.33. Okay, so now T4 dash P4 dash is your 1.2, P3 is your 9.8. Okay, you can mention here P4 dash. Okay, this is your 1.2 bar. Okay, so it's 0.33, 1.33. T4 dash thousand 9.6 Kelvin. Okay, what is turbine efficiency? 0.86 is equal to T3 minus T4 T3 minus T4 divided by T3 minus T4 dash is equal to 1700 minus T4 okay. So now what is your what? T4 1106.3. So now you know the exhaust is cooled in where? A regenerator. Okay, so what does it mean? And what is given? Epsilon is equal to 0.75. Okay, so epsilon is equal to 0.75 equal to okay Tx minus T2 okay Tx minus T2 divided by T4 minus T2 is equal to T4 minus Ty divided by T4 minus Ty divided by T4 minus T2. Okay. So first, now find out what? Dx. Okay. So Tx is equal to T2 plus 0.75 into what? T4 minus T2. Right. So 603.34, 0.75, that is T4 1106.3 minus 603.34. What is Tx? 980.53. Okay. So heat input Qi is equal to mCp T3 minus Tx. Okay, what is M? 100, Cp 1.005, T3 is 1700, X Tx 980.53. Now we found out. So what is Qy? 7306.735 kilowatt. Okay. So total work, turbine work minus compressor work. Okay. Turbine gas, compressor air. Okay. Okay. What is turbine work? MA CPZ T3 minus T4 minus MA CPA T2 minus T1. Okay. W total 100, 1.15, 1700, 1106.735 minus 100, 1.005, 603.34 minus 288. You solve, you will get 3653.83 kilowatt, 36.534 megawatt. Okay, so now what is the power output? Power output or total power P total PT equal to WT into mechanical efficiency alternator efficiency and what? Thermal efficiency. Okay, this is what the things you should multiply. This is your mechanical efficiency, alternator efficiency, thermal efficiency. Okay, $36.534, 0.98, 0.98, 0.5. $17.54 megawatt total power. Okay, or output power. Okay, so what is the thermal efficiency? Okay, actually thermal efficiency not given in the question, but I found out 0.5, so directly I put in the output power. Okay, so that's the reason I again finding out to show you the thermal efficiency is coming out to be 0.5. Okay, because it's not given. Okay, I just get to know now. So W out, very simple, divided by inlet temperature. Okay, W out, or you can write on total, na? Yeah. Okay, what is total power? 36533.83 divided by 72306.735 into 100. Okay, thermal efficiency 50.53. Okay, with this we can end the section. Thank you very much for attending the section. If you have any doubt, you can ask me in my YouTube channel Sumit Sagar Hota in the comment sections. If you have any other doubts, you can ask also in the NPTEL question and answer forums. Okay, thank you very much for attending the section, and good night.